Hello everyone. The color of the sky is not actually blue, it's black. That's what we see at night. So I'm going to put a cross right next to it. Now, sunlight, as you may know, or you may not know actually, is not actually yellow. The color of sunlight is white. So I'm going to put a cross next to that. And did you know or not, but the color of water is actually blue, which is the opposite of what people believe. Water is not colorless. Water actually has a blue color, or it has properties that make it appear blue. So that's what I'm going to discuss in this video. This video will be a story of light, of color, of vision and color perception, a story of physics, and there'll be quite a bit of physics, of sunsets and why sunsets appear to be red when, in actuality they're not really, about oceans and why oceans are blue, and how water is actually blue and water is not colorless, and why water in a glass appears to be colorless when it's very slightly blue. Now, to explain all of these principles, we're going to have to look at a phenomena called Rayleigh scattering. So assume a box or any holder or container with gas, any sort of air in it, air particles, and these air molecules are all moving at random velocities, and we shine a light through this container. What do you think is going to happen? Well, first of all, we'll see some of the light rays deflect because of the air molecules, and the air molecules which are in the path of the light will cause the light to change direction. Now, the air molecules must be much smaller than the wavelength of the light. The maximum they can be is 10 times less than the wavelength of the light. So this requires very small particles. Now, our vision consists of a range of colors from red to violet or indigo, depending on what you call it. And this goes from 740 nanometers wavelength to a shorter 380 nanometers for violet. Now, the power and intensity of the scattering of light in Rayleigh scattering is proportional to 1 over the 4th power of lambda, or the wavelength. What this means is, as the wavelength decreases, the probability that light will scatter and the amount of light scatters increases. So in short, red light scatters less because it has a longer wavelength, and indigo or violet and blue colors scatter more. Now, if you double the wavelength, then the intensity or power goes down by a factor of 16, which is 2 to the 4th power, because there's lambda to the 4th power in the equation. And if we look at graph at the intensity versus the wavelength, this is the shape you will see. So what did we learn? Basically, we learned that blue light scatters more than red light because it has a shorter wavelength. Now consider you standing and looking at the sky towards the sun. Never do this, by the way, it's harmful for your vision. So the light that the sun emits consists of different wavelengths, and visible light falls roughly in the middle of that spectrum. And because of nature or natural evolution, we're designed in a way that we are most sensitive to these colors. Now, imagine the sun's rays coming and hitting your eyes. Because of Rayleigh scattering, the blue rays in the spectrum will be scattered the most, and thus the sun's light will appear relatively reddish or yellowish, which is why the sun appears to be yellow when it's actually white if seen from space. Now consider the rays entering the atmosphere in other parts, not directly aimed at your eyes. Blue light that scatters from these parts will end up in your eyes, causing you to perceive those parts as being blue. Now you might be wondering, well, why are there light rays in regions where there's no sun? Like, how did those rays get there? And that's because the sun is actually much bigger. This picture shows a much better scale of what the sun would look like. However, even this picture is not fully accurate, as the sun would still be it's still not to scale, because the sun would still be millions of times larger than what it actually shows. So many people think that the oceans appear yellow because this blue sky, light from the blue sky, hits the oceans and hits your eyes, and so you see the oceans as being yellow. This seems like a fine theory, but it's actually not the reason why oceans appear to be blue. You see, this is wrong. Oceans are actually blue. They're blue because of their own properties. You see, water has a property where it absorbs colors such as red, such as orange, yellow, green, all the reddish colors, and even up to green, but it scatters the blue light, causing the blue light to fall to your eyes and making you perceive the water as blue. But why don't you see a glass of water as being blue? Well, simply because the volume and depth of a glass of water is very less, and so the amount of blue light it lets through and the amount of other colors it absorbs is negligible, which is why you see a glass of water as being colorless, even though it's actually very slightly blue. It very slightly lets through more blue light than it does other colors. But because this difference is so insignificant, the light enters in relatively similar quantities, and when it hits your eye, you think that's white, but it's slightly more bluish than true white. Hopefully, I've managed to successfully explain this concept to you. If you enjoyed the video, please give a like, and please consider subscribing, as it really helps to support the channel. I'll be posting many more videos. Have an excellent day.